Chapter 5, Section 6, Merging Exponents and Roots. So in this section, what we're going to do is we're going to learn how to deal with fractional exponents and what they actually mean. Anytime you see a fractional exponent, you're actually looking at a radical. Anytime you see a fractional exponent, you are looking at a radical. So what we're going to do is we're going to learn how to go from fractional exponent to radical expression and then learn how to simplify it from there. So if you notice, if you have a base raised to a power, what you have is that power, that fractional exponent, your numerator becomes your exponent and your denominator is going to be your index. So it's always power over index. It's always power over index. So if we have something like 25 raised to the 3/2 power, 25 is your base, so it's going to turn into your radicand. Your base is going to be your radicand. Your numerator is going to be your power, and so you can put it on the inside or you can put it on the outside. You can either put it here or you can put it here, and it depends on the problem where I put it. For this one, it's going to be easier for me to put it over here. So power over index, so the 2 is your index. So the top number is your power, and the bottom number is your index. So now this is telling me to take the square root of 25, which is going to be 5, and then cube that. And then 5 cubed is going to be 125. So what happens if you have a negative exponent, a negative power? Well, remember, if you have a negative power, we learned this at the beginning, you're going to take the reciprocal of it. So this is going to turn into 1 over 32 to the positive 2/5. And so now we need to turn that into a radical. So we're going to have 1 over 32 is going to be your radical. And you're taking the 5th root and then you're going to square it. So 1 over the 5th root of 32 is 2, and then we've got to square that, so you're going to get 1/4. So how did I know the 5th root of 32 was 2? Well, in your calculator there is a button that looks like this, and that is the nth root. So to do this, depending on your calculator, for my calculator, I would hit 5 and then shift nth root 32, and it should give you 2. So if you can't figure out how to work your calculator, bring it into class and I'll show you how to do that. Okay, so what about this one? This time your radicand is negative. So we're going to have negative 64 because that's our base, and it's telling me to take the cube root because that's my denominator. So take the cube root of negative 64, and then that numerator tells me that I'm going to square it after I do that. So the cube root of negative 64 is going to be negative 4, and then negative 4 squared is going to be 16. Be careful with those signs. Okay, this one again, my radicand is going to be negative 8. The denominator tells me that I'm taking the cube root, and then it's going to be raised to the 1st power, so we really don't have to do anything there. So the cube root of negative 8 is going to be negative 2 raised to the 1st power, which is negative 2. So again, the main thing that you've got to remember is power over index, power over index. And it doesn't matter if you put your power on the inside or on the outside. Obviously, I like to put it on the outside. Okay, so to write a radical expression using positive rational exponents. So again, what we're going to do here is we're going to take our radicals and we're going to learn to go the other way. So on the previous slide, we took our fractional exponents and learned how to make them into radicals and simplify. Sometimes you have radicals that you need to work with, but you can't because the indices are different. And so that's why you would need to change a radical to a fraction with exponents. So the index is your denominator, so this is a square root. The index is your denominator. The exponent is your numerator. It's still power over index, and the radicand is the base. The radicand is the base. So this is going to be, my radicand is going to be my base, and it is a product, so I need to put it in as a group. So you're going to have xy. The power is 1, so it's going to be to the 1/2 power over index. So if you want to, and I think this is how your book writes it, they go ahead and split it up. It doesn't matter to me either way. Okay, so for here, a cubed b is going to be my base, because that's my radicand. And then it's going to be raised to, I'm going to make this understood to be 1/4. It's going to be raised to the 1/4 power, power over index. And now, the a is going to be, remember when you have a power to a power, you're going to multiply. So a is going to be raised to the 3/4 power, and b is going to be raised to the 1/4 power, because there is a 1 here. So 1 times 1/4. So all I did is I multiplied, I raised my a to the 1/4, so a to the third to the 1/4. You're going to multiply 3 times 1/4 and get 3/4. And then b to the first to the 1/4 is just b to the 1/4. Okay, here. The 4 has nothing to do with this radical. So that says 4 times. So we're going to write it as 4 times. X is your base. And we're going to raise that x to the 2/3 power, to the 2/3 power, power over index. So to write this the way you're used to seeing it, it's just going to be 4 times x to the 2/3. That 2/3 has nothing to do with the 4. Alright, so for this one, this time our base is going to be that group of x plus y, and it's going to be raised to the 4/5 power, power over index. So you have x plus y raised to the 4/5 power. So what is the difference between this one and this one? This one, since it's straight multiplication, I could distribute that 1/4 to both of these factors. But this is addition, and you cannot distribute a power over addition or subtraction. So this one has to stay like this. That is going to be your answer. So be very careful with that. Alright, so let's look at these. And again, you're basically what you're doing is you're using your rules for multiplying and dividing exponents that we learned back in chapter 3. So, when you have, when you're multiplying monomials, remember you're multiplying coefficient times coefficient. 3 times 4 is going to be 12. And then when you multiply powers with like bases, you add these exponents. So you have x to the 1/2 plus 2/3. Now you don't have to write that out, but I did just so that you could see what's going on. When you multiply powers with like bases, you add those exponents. So in your calculator, if you need to, just put 1/2 plus 2/3, or if you can do that in your head, that's fine too. But we don't need a mixed number. We need an improper fraction. So what we're going to get is 12x to the 7/6 power. So, no mixed numbers, just leave it as improper. Use your calculator if you need to. If you don't need to, that's great. But if you don't have a calculator, remember you've got to have common denominator before you can put those together. Okay, so here we have a monomial factor. You have monomial raised to the 2nd power. So each one of these gets raised to the 2nd power. And again, we did this in chapter 3. The only difference is we're using fractional exponents. So we're going to have 5 squared times a to the 1/3 squared. Clean that up. Times b to the 1/2 squared. So this is going to turn into 5 squared is going to be 25. Power to a power you multiply, so you're going to have a to the 2/3, and you can put that in your calculator if you need to. And then half b to the 1/2 squared. I don't really know how to say that, but b to the 1/2 squared, you're just multiplying 1/2 times 2, so I look at it as half of 2, which is going to be 1, and you don't even have to write it if you don't want to. But so your answer is 25 a to the 2/3 b to the 1st. So what if you're dividing powers? Well, dividing powers, you subtract those exponents. So we'll divide 12 over 6 like we normally would and get 2. And then you're going to have y to the 1/3 minus 1/2. It's always top minus bottom, remember. And again, we did this in chapter 3. So you can put that in your calculator if you want to. Basically, you're going to get 2, and then 1/3 minus 1/2, and you're going to get negative 2y to the negative 1/6. And remember, none of your answers can have negative exponents. So that negative 1/6 has nothing to do with the 2 because the 2 has its own power. So it's going to stay on top, but we're going to put y to the 1/6 on bottom. Okay, down here we have products and quotients, so everything gets that 4. So you're going to have 3 to the 4th power, x to the 2/5 to the 4th power, 2 to the 4th power, and y to the 2/3 to the 4th power. So 3 to the 4th power is going to be 81. And then x to the 2/5 to the 4th power is going to be x to the 8/5. And then 2 to the 4th power is going to be 16. And then y to the 2/3 to the 4th power is going to be y to the 8/3. And I don't think any of that will simplify, so that's going to be your answer. Alright, so why do we need to know how to go from radical to fractional exponents and then back to radical? Well, this is why. Because like I was saying earlier, you can multiply any radicals that you want to as long as the indices are the same. If the indices are different, like we have here, we have a square root and a cube root, you cannot multiply these together. But we do have a trick that we can use. We can use that power over index. We can change it to a fractional exponent. So we have 2 to the 1/2 times 2 to the 1/3. So you cannot multiply radicals that have different indices, but you can multiply powers with like bases. When you multiply powers with like bases, you add those exponents. And so we're going to have 2 to the, let's see, 1/2 plus 1/3 is going to be 5/6. But then, since you started with radicals, you have to end with radicals. So this is going to be the 6th root of 2 raised to the 5th power. And this is good for me, or if you want to go ahead and simplify it out, you can have the 6th root of 32. So, one more time. How do I know when I need to change my radicals to fractional exponents? If you are multiplying or dividing radicals that have different indices, before you can do the multiplication or division, you must change them to fractional exponents. Then you're going to have like bases, hopefully. And when you have like bases, when you multiply powers like bases, you add the exponents. And then you change, make sure you change your fractional exponent back to a radical, since that's what you started with. Okay, this one, the bases are not the same, but I can take the square root of 4 and get 2. So this is going to be 2 to the 1st power over 2 to the 1/3 power. So you're going to get, when you divide powers with like bases, you subtract those exponents, so you get 1 minus 1/3, 1 minus 1/3. And again, you can put that in your calculator, so you have 1 minus 1/3, and you're going to get 2 to the 2/3. But again, make sure, since you started with radicals, you change it back to a radical. So you're going to have the cube root of 2 squared, and if you want to go ahead and finish that out, it'd be the cube root of 4. So I want you to try these problems on page 279 and 280. Bring them into class if you have any questions.